So now let's start using those numbers to actually do the math. This is the data table you're going to use. If you'll notice, I've given you the data for 2 more salts, but I'm going to walk you through these calculations so that you'll know exactly how to do them. I'm going to walk you through with the copper sulfate example, and then you will do the strontium chloride and barium chloride examples. All right, mass of the crucible. Let's run back up here, and the mass of the empty crucible was 20.921. Okay, gram is already over here, so I really don't have to write it. Now it wants the mass of the hydrated salt. How much of the hydrate did we begin with? Remember I told you that I tared the crucible to 0 and then I added salt. So this mass is the mass of only the hydrate in the cup. So 1.254. Now the mass of the crucible and the anhydrous salt. So it's anhydrous, which means that's going to be after heating. And we weighed that in the crucible without transferring it so that we didn't lose any on transfer. So that mass, remember the anhydrous in the crucible and the crucible itself, 21.717. Okay, so these three, all three of those come from experimental data. The rest of this is going to be calculated. Okay, so the first 3 lines are what you would get directly from measurements in the lab. The rest of this we're going to figure out by doing some simple math. All right, so we need the mass of the anhydrous salt for the copper sulfate. How are we going to go about doing that? Well, let's come down here and let's go through this logically. If we need the mass of the anhydrous salt, just the anhydrous, then we're going to have to realize that what we know is the mass of crucible plus anhydrous. We know that number. We also know the mass of just the crucible. So if we subtract those, that should leave us with the mass of the anhydrous that was actually left in the crucible after heating. So come back up here and get the numbers you need. Mass of the crucible and anhydrous was this guy, 21.717. Mass of the empty crucible was this one, 20.921. Subtract those, you're going to get 0.796 grams of the anhydrous, which for us is CuSO4. So mass of anhydrous salt, 0.796 grams. Now, if we're trying to get a formula, formulas are counting ratios. We count in moles. So the mass is obviously something we need, but now we need to take that mass and transfer it into moles. So 0.796 grams of CuSO4 we need to go to moles. So 1 mole of CuSO4, and this is just the anhydrous part. It's just the cations and anions. It does not have water in it. So we should not be adding up any water at this point when we're adding up its formula mass. So we're going to add 1 copper, 1 sulfur, and 4 oxygens together. When you do that properly, you're going to have 159.62 grams of copper sulfate is what you would have to have a whole mole. So we only have 0.796 grams. So when we do that math, that's going to be 0.00499 moles of copper sulfate. All right, so now we know how many moles of the salt were actually present. If we want to be able to get the formula of the hydrate, now we need to know how many moles of water was lost. Well, let's take the numbers we just solved for first and fill them into our table. So moles mass of anhydrous was this guy, 0.796 grams. The moles of anhydrous we just solved for, and that was the 0.00499. All right, now we need the information about water. Well, we know the mass of the hydrate we started with, which was salt and water together. We also know the mass of the anhydrous salt left behind. We solved for it right up here. All right, so let's run back up and find the mass of the hydrate we started with. Mass of hydrated salt that we began with was the 1.254, and that was of the copper sulfate with the water in it. So if we subtract just the salt from the hydrated salt, what we should be left with is the mass of water, which was removed on heating, and that is going to be 0.458. Now, once again, we're doing a formula, which is a counting ratio, not a mass ratio. So we're going to take that and we're going to transfer that to moles. 0.458 grams of water. Then if you add up 2 hydrogens and 1 oxygen, that's 18.02 grams of water to 1 mole of water. And that's going to give you 0.0254 moles of H2O. Now we have a mole ratio, but that is not ready to be written as a formula. We need the mole ratio between anhydrous salt and water in the hydrated salt in our sample to every 3, 2. So if we bring the numbers of moles down, we know right now that it's 0.00499 moles of the salt, copper sulfate, per 0.0254 moles of water. From our math, that's what we know is present. We need to now simplify that. It should have a 1 in front of the salt formula. So if we come back down here, the way we're going to do that is to divide by the moles of copper sulfate such that it ends up being a 1. But you'll need to divide both sides by that for the ratio to be the same. When you do so, you're going to get 1 mole of CuSO4, a 5.09 moles of H2O. So this is going to be your experimentally determined mole ratio. So let's look back up at our data table, because there's a place this needs to be filled in. To 5.09 is the ratio we got from our experimental numbers. Now we need to grab the water numbers. We forgot to fill those into our table. Let's come back down here. It was 0.458 grams of water. That's how much water we removed on heating. We transferred that to moles, and we got 0.0254. And we took those mole numbers, we divided both by the smallest, which is the moles of anhydrous, and we ended up with a 1 to 5.09 ratio. Now, if we take that ratio and we round it to a whole number ratio, we're going to have 1 mole of CuSO4 to every 5 moles of H2O. So from our data, we were able to determine that this is a 5 when this is a 1. So now we need to write that in the proper format for the chemical formula of a hydrated salt. The 1 is understood, so you do not write that. Between the formula of the salt portion and the water trapped inside, we put the big old bullet. And then it is 5. You don't say moles, you just put the 5 in front of the formula of the water. And that answer would go in your table as well. So when you take your 1 to 5.09 and you rounded it, you came up with 1 to 5. And your complete hydrate formula, CuSO4 dot 5H2O. And to do your percent error, that will be the difference between the 5.09 minus the 5 in the numerator divided by the theoretical and true value of 5 times 100. And you're going to have a percent error equal to 1.8%. Which is pretty darn good. Put back up here and put in 1.8%. So that walked you through how to collect the data as if you were in the lab, and exactly how to walk through all this data to do the calculations to get to the actual formula of the salt and the percent error. Your job is now to do exactly what I did for the copper sulfate sample, but you're going to do that for 2 more salts. So you should have all of this. You should have that for both the strontium chloride salt and for the barium chloride salt. So you're going to fill in these tables with all of the data as you go, just like I did, and you're going to show me all that work. It needs to be clean, neat, handwritten, and you will submit those on your report sheet. Take pictures of each page, put those pictures into a single document, either PDF or Word document, and then that will be put into the designated Dropbox in our lab eLearn site. Check your schedule for due date, please.